In this section, we're taking what we've learned in the past few sections with adding, subtracting, multiplying, mainly multiplying fractions and mixed numbers, and we're applying it to converting between measurement systems. If you haven't already, you will want to turn to page 320 of your textbook and copy down the chart that is on that page, the conversion chart, with length, weight, and mass and capacity conversions from the metric system and or to the English system. Actually, it's in the opposite order, going from the English system to the metric system. You want to learn, you want to memorize at least one from each of these. If you have one of them and you know the conversions within each system, in other words, inches to feet, feet to yards, so on and so forth, and then millimeters to centimeters, centimeters to meters, so on and so forth. If you know those and one from each of these, length, weight, mass, and capacity, then you should be able to convert any values that you're given to any other unit. You might want to learn all of them if you plan on taking advanced level mathematics courses. So in light of that chart on page 320, again, copy it to your notes. With part A, we're given 3.5 miles to kilometers. Now, the textbook doesn't always do this, but I am going to write this as a fraction, a rational number, over 1. 3.5 miles to 1. And the reason for that is because we're using what you will later know as unit analysis. And with unit analysis, we're multiplying fractions, and we're trying to cancel the term that we start with, the unit that we start with, in this case miles, using conversions, ratios of conversions, to get to what we're looking for, the unit of kilometers. So if we look at that chart on page 320, it says 1 mile is 1.61 kilometers. So we can go directly from miles to kilometers. And what we'll want to do, we know we want to get rid of miles. And it says that there's 1 mile, and we want to go to kilometers. And we won't have to go any further than this. We won't have to use conversions within the same system because we're going directly from miles to kilometers. And again, there are 1.61 kilometers in each mile. So we know the miles cancel. So we're only left with 3.5 times 1.61 kilometers. We'll go ahead and multiply out the 1.61 times 3.5. 1 times 5 is 5, 6 times 5 is 30, 0 down, I carry my 3, 1 times 5 is 5, plus 3 is 8. Put a 0 here to move over, 3 times 1 is 3, 6 times 3 is 18, 8 down, carry a 1 this time. 1 times 3 is 3, plus 1 is 4. Then we add these, 5, 3, 16, 5. And there were 3 decimal places, so we move this over 3 decimal places, so it's 5.635. And we're asked to round to the nearest hundredth, so this would be 5.64 kilometers. Now, meters to feet, we're given 1,600 meters. Again, I'm going to write that as a rational number with a denominator of 1. And if we look at that chart on page 320, we are given that 1 foot is 0.3 meters. We know we're wanting to get rid of meters, and since we have meters to feet, we know we're going to convert directly. There are 0.3 meters in each foot. The meters are going to cancel, and we're left with 1,600 divided by 0.3 feet. Now again, we're going to have to use long division here. Well, we wouldn't have to, but we're going to. We're moving the decimal place over 1, so we move it over 1 here. And we're looking at how many times does 3 go into 16,000. So 3 will go into 16 5 times. So 1, bring down your 0. 3 will go into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down your 0. Again, that's 3. And this is just going to keep repeating. So using the chart on page 320 of your textbook, 1,600 feet is going to be approximately 5,333.33 feet. 1,600 meters is approximately 5,333.33 feet. And there are actually other conversion charts that would use a more accurate conversion than 0.3 meters. You're actually looking at more around 0.305, which would give you a little bit different solution. That would end up giving you 5,245. So it does make a substantially big difference between the approximation using 0.3 and a conversion factor that's a little more accurate. All right, we'll move on to parts C and D. With part C, we have pounds to kilograms. Again, we reference our chart. We know that there's going to be pounds in the numerator, 4 pounds. I'm putting it over 1 times. Let's make sure we have pounds and kilograms in our chart. We are given pounds to kilograms as the second item in that chart under weight/mass. And we're given that 1 pound. So we're going to have pounds in the denominator. In our conversion, we're given 1 pound to kilograms. So we know that 1 pound is approximately 0.4536 kilograms. The pounds cancel, and we're left with 4 times 0.4536 kilograms. If you multiply that through 4 times 0.4536, that's 1.8144 kilograms. And then rounded to the nearest hundredth as asked for, that is approximately 1.81 kilograms. With the last part of example 1, we are given 6 gallons and we're asked to convert that to liters. So again, we look at our chart and first we write 6 gallons. Again, that's over 1 times. And under capacity, we are given that 1 gallon is 3.79 liters, so we can make that direct conversion. We're given 1 gallon, so we put 1 gallon in the denominator. We want liters, and we're given that 1 gallon is 3.79 liters. The gallons cancel, and then we have 6 times 3.79 liters. And then 6 times 3.79 is 22.74 liters.